In this video, we're going to look at a couple ways that you can graph a linear equation. These are not the only ways. We're going to explore some other options in other videos. But for today, let's look at a couple ways that we can graph linear equations. The first way we're going to look at is using an XY table. So that's going to look something like this. And we are going to fill in some values for that XY table. Now you can put in anything you want. I like to start with 0, but it's not a requirement. But we're going to start with that for now. And what I'm saying by putting that 0 there is that I want my X value to be 0. And if that's true, I need to know what the Y value is going to be. So back over here with this equation, we're going to let X equal 0 and see what happens. So wherever I see an X, I'm going to swap it out for a 0. 1/3 times 0 is still just 0, and 0 minus 2 is -2. So whenever we put in 0 for X, the equation spits back at us that Y is -2. That tells me that the point 0, -2 is a point on this line. Let's find some more points. Now you can put anything you want in the X spot, or you could even put something in the Y spot if you wanted to. But that 1/3 is going to make this a little tricky. I don't want to get nasty fractions. And so let's be smart about this. I want to put things in here for X that when we multiply them by 1/3, they're going to work out nicely. So things that we can do a third of would be any of the multiples of 3. So 3 would be a good choice. Let's put in 3. So what happens when X equals 3? Let's rewrite our equation. But instead of X, this time we put in 3. 1/3 of 3 is just 1. And Y then is going to be -1. So when we put in 3 for X, we got -1 for Y. That means the point 3, -1 is a point on my line. Technically, we could connect the dots and call it done. We have a line. But to be safe, I always like to do a third point, because when you do the third point, you're going to see that they all line up very nicely or they don't. And if they don't line up nicely, you've made a mistake, and it's a nice way to catch a quick mistake. Let's do one more. So again, I'm looking for things that work nicely with 1/3. So that's going to be like 3, 6, 9, all the positives and the negatives. I think I'm going to just put in 6. Let's try when X equals 6 and see what happens. So again, we're rewriting this, but instead of X, we're putting in that 6. 1/3 of 6 is 2, and 2 minus 2 is 0. So the point 6, 0 is on our line. Those 3 points line up in a straight line, so I'm feeling pretty good about that. And then we're just going to connect the dots. Now don't stop there. Remember, we could put anything we want in this XY table and get a whole bunch of points. That is not it. This line does not start and stop with my points. It goes forever. There are an infinite number of points that are going to work. So we need those arrows to show that everything on that line, even if we extended it forever, would work in this equation. Let's try another technique for graphing a line. In this technique, we're going to use the X and Y intercepts to graph our line. The x-intercept is where this line will go through the x-axis. Think about what kind of points go through the x-axis. If our point is going to be on the x-axis, it can't be up and down, which means the y value would be 0. So anytime you're going to look for an x-intercept, we know that you're going to have a point with an x, but no value in the y, or y is going to be 0. So we're going to rewrite our equation for our line, but instead put 0 in the y spot. So wherever you see a y, we're going to swap it out for 0 and find the x value. So for this one, -3 times 0 is just going to be 0. And x plus 0 is just x. And so we know the x value would be -6 when the y value is 0. That is our x-intercept. So that tells me it goes through the x-axis right here at -6. Next, we're going to find the y-intercept. This is our y-axis. So we want to know, where does the line go through the y-axis? So if you think about what that means for a y-intercept, we're going to have a point that's going to have a 0 or no side to side in the x spot and some value for the y, meaning we want to know where is x 0. So we'll rewrite our equation, but instead of x, we're going to put 0 in its spot and solve for y. 0 minus 3y is just -3y. And then to get y by itself, we're going to divide by -3, which gives me a y value of 2. The y-intercept then is 0, 2. So that means right here, this line goes through the y-axis. Now that we have our x and y intercepts, we can just connect those dots. Remember, this line goes forever, and we have our line. You could also plug in another point for x and y. Maybe put in a value of like 2 for x and see what you get for y, and see if it shows up on your line. It's a quick check to make sure that you didn't make a mistake in finding your x and y intercepts. Because remember, every point along this line should work in this equation. Let's take a look at example 3. This equation says x equals -5. That seems a little strange because most of the time when we graph these lines, we would have an x and a y in them. And this one only has an x. So if you were to think about maybe making an xy table for this, the only thing x can be is -5. But it doesn't talk about y. So y can be anything here. Y could be 0. You could also make y 1. You could make y 3. You could make y -3. Doesn't matter. What matters in this is that x has to be -5. Now, if you think about those points that we just put in our xy table, they are all going to line up where x is equal to -5, which is right here. Now, that point isn't our only answer. It's every point all along the line where x is equal to -5. So when it asks you to name 2 ordered pairs, you can pick any ordered pairs you want as long as the x value is -5. So I'm going to do -512 and -5 and 200. But you could pick anything. Like over here on our table, we have -5, -3, -5, 0. All of those points are going to be on this line. The only condition is that x has to be -5. So anytime you get an equation where it asks you to graph and you're missing one of the letters, it's going to be one of these special cases where it's either a line going up and down like this, a vertical line, or it might be a horizontal line. Let's look at one of those. In example 4, we are missing some x's, but here we have y's. Now this one's kind of in a different format. So before we do much with this, I think moving some things around and making the y's on one side and the numbers on the other will help us. So let's first start by moving this y over here so that my y's are together. So this is going to be 2y minus 8 now. And over here now I have nothing. And to get the 8 on the other side, let's add him over. And so we're going to have 2y equals 8. And to get y by itself, we would divide by 2, and I would get y equals 4. Now this looks a little bit better. It looks more like the last one where we had x equal -5. This is telling me that if we were to make an xy table, the y has to be 4. But the x can be anything you want as long as the y is 4. So we could make this 2, 0, -1. It doesn't matter as long as the y is 4. Well, where is y 4? That would be right here on our graph. But all of these points along this line forever have a y value of 4. So when it says name two ordered pairs, you can put anything you want in the x spot, but the y value has to be 4. How about -217, 4? Also a point on this line. Anything you want will work here as long as the y value is 4. So when you get x equals a number, like we did on the last one, you get a vertical line. When you get y equals a number, that's going to give you a horizontal line. I don't think memorizing those two facts is the best way to do this. I think the best way to do this is get it simplified, know which one you got here. This is y equals 4. So that means all of the y's have to be 4. And if you graph those points, you're going to see which line it is, vertical or horizontal, very quickly without having to memorize which is which. But it is important to identify if you only have y's or you only have x's, it's going to be one of these special cases where it's a horizontal or vertical line.